everybody. Hello, Tom. Good to have you here. And I was in Austria a few years ago. Beautiful country, especially Vienna. And when I was there, I realized there has been many cultural exchanges between Iran and Austria many years ago. During the Habsburg dynasty in Austria and Qajar dynasty in Iran, there was a lot of exchange between the countries, and I'm glad that it has continued today. And it's an honor to have you here with us, and I hope architecture would become a good medium for these cultural exchanges. There is many things we can learn from Austria, and I hope there will be some few lessons to learn from Iran. And in this regard, I'm going to talk about the traditional architecture of Iran. As everybody knows, Iran has a very long history of architecture, from Stone Age to present time, and there has been many great achievements. In regard to climate and energy, also traditional Iranian architecture has many great achievements. And in each part of Iran that you go even today, you can see traditional buildings which was designed in regard to climate. If Louis Kahn says form follows function, which is a motto of modern architecture, in traditional Iranian architecture, form follows climate. And it is the climate that determines the form of the building. And in different climatic regions of Iran, we can see different shapes, different materials, different everything, which I'm going to explain, that how climate has affected our architecture in the past. But with the advancement of technology, especially when modern architecture came, climate was pushed to the corner, and it was technology that was important. But now we have realized that technology is very good, but it's also very bad. And this technology can destroy our modern earth, because this technology uses a lot of energy, a lot of material, a lot of resources, and our mother earth has very limited resources to provide for our building industry. So we have to look back again at our traditional architecture to see how they used in an efficient way energy, resources, and how they provided comfort with low-tech facilities. If today we are using high-tech, in the traditional architecture of Iran, it was low-tech, and they provided comfort with low-tech. So, since I have only 20 minutes, I'm trying to push everything together in 20 minutes. I have 3 slides to show, and in each slide I'll try to explain how climate affected our housing design and how we can learn from these in our today architecture. So, if you allow me, I'm going to start my presentation. This is Iran. Can you see my browser when I move? You see my browser? No? You have my voice, you have my browser, you see my browser? What I want to speak here is, this is Iran. 1 second, let me see. شما این براوزر من که بودم میبینید براوزر منو؟ نه
بله مشکلی نیست همه چی بله هیچ مشکلی نیست بله
ایران ایران has 4 different climates Caspian Sea, Persian Gulf and Iran. In here we have temperate climates next to the Caspian Sea and Mediterranean climate. Region 2 is mountain and high cloud, cold climate. So in this year we have cold climate, hot and humid climate. We have big deserts here. So here it's like hot and humid. Okay, I'm sorry. In here, hot and dry. So this is hot and dry or hot arid. And in here, by the Persian Gulf and Sea of Oman, we have hot and humid. So we have temperate with a lot of rain, cold, hot and dry, and hot and humid. Different climatic condition, we have 4 different kind of houses. In here, which we have a lot of rain, the traditional architecture comes out with this kind of houses. Gable roof, colonnade house, and building was built a little bit above the natural ground. So in this way, you get the rain of the building and you bring cross ventilation into the house. It comes from one side, it goes from the other side, and because it rains, a lot of ground is very damp. So they build the building above the ground to be away from this dampness. So it rains a lot, and you will be here comfortable with cross ventilation and no rain and no dampness. And was timber, plant material, and masonry. So whatever they had at their disposal, they would use for the material. So this is region 1, which is by the Caspian Sea. Region 2, we go to this hot and dry. Dry. Central Plateau, hot and dry. In here we have central courtyard. This is called 4-season house. In winter time, the family resident would become on this side because here you have direct sunshine. It's warmer in winter. In summertime, they come and they live on the south. So this is the summer quarter, and this is the winter quarter. In winter time, they live in this side. In summertime, they live in this side. And the building is completely enclosed. There is just one inside, and from the courtyard, you have access to all parts of the building. Ventilation, you have these wind towers. In summertime, they open these wind towers. Wind comes in, goes into the room. So in summertime, you also have cross ventilation. The wind comes in, goes into the building, and goes to the courtyard. So this is dry climate. When you go to cold climate, again you have a central courtyard. Again, this is north side. This is north side here and north side. In here, the winter quarter living, because the family most of the year lives in time, because summertime is not very hot here. So they live in this side in winter time, And for the summer, there is just a balcony or veranda on the south side, but most of the living is here. Again, you have a set of wing, and all the access to different parts of the building is from the courtyard. No wing tower, because here it is not equal. Central courtyard, but here the summer quarter is very big, and the summer living quarter is not very big, and the winter living quarter is big. But both of them, you come in from this entrance, and all the access is central courtyard. Four follows glide. When you go to this region, which is hot and humid, it's by the Persian Gulf, there is no Iraq, Libya, Pakistan, so in here it is and very humid. So for this climatic, we have come up with this kind of form. Again, you have a central courtyard. But, humid, you need a lot of cross ventilation. You have openings on the inside, openings on the outside. And you have a lot of wind towers. So in this way, all the rooms have cross ventilation. The depth of the building is one room. So there is one room. All the circulation is through the courtyard. So in all the rooms, in and out. And also you have wing tower. So in here, cross ventilation is very important, and all the buildings have access to windows. There is one other region which has a particular kind of architecture. Here is Uzbekistan, it's near the Iraqi border. In here we have a particular kind of architecture. Something between hot and dry and hot and humid right here. So it's hot, but it's on the borderline between and hot and dry, which is here. So it is hot and semi-humid. It is in Uzbekistan province. In here, you again have a central courtyard. Again, this is north side. Because it is hot, we have openings on the outside, and we have openings on the inside. The summer living quarter is very big. Winter living quarter is very small because it is hot. So they live on the south side. And on the north side, if you have direct sunlight and it is warmer, there is no living. So if I go one more time, this is by the Caspian Sea, lots of rain. It is now housing shape. But in the mainland of Iran, you have all types of courtyard houses. All of them courtyard houses, but with different shape. In here, which is hot and dry, this is winter living quarter. Summer living quarter. Summer living quarter is always in shade. Winter living quarter is always has access to direct sunlight. Here is warmer, is winter. When you go to cold climate, winter living quarter becomes big, summer living quarter becomes small. I can see when you go to the Persian Gulf and Sea of Oman, hot and dry, you come up with this kind of shape. Cross ventilation becomes important. And in here, which is hot and semi-humid, summer living quarter becomes very important. Winter living quarter is not. So, as a conclusion, what I want to say here is, with minimal resources, material, it would provide support for people to live in. Right now, but we have to realize that our planet has limited resources. So we have access. But they provide protection and comfort for people to live in. Those lessons for today is for them, for our children in the future. Thank you very much. And I'm going to listen to Thomas for his great presentation.
Good evening again. Thank you for the invitation. And I'm Thomas Lum from Vienna. I'm an architect with a practice in Vienna, architecture practice in the Third District, and my practice is called Forschen, Plan, Bauen, which means research, planning, and construction. And this is what we're going to talk about today. We're going to touch all these three fields of my work, and I hope you will enjoy. And I resume all these three issues to one word, to one title, and this is circular architecture. So I'm very much interested in the in resources in general, and energy, and energy, of course, as a part of resources. So, like Vahid said, climate is actually the most important design impact and design factor for architecture, of course. And I also agree that low-tech solutions are the solutions of our time, and we have to go back to this. But let me start, please, with a short introduction into the theme of circular architecture, and let's talk about my research, my recent research. I did a project with the agency, with the environmental agency of Austria, which I called Kreislaufbauwirtschaft, which means circular construction economy. So we were thinking about how to come to standards of a new circular construction economy in Austria, and because, like Vahid said, we are running out of resources, and the circular material use rate in Austria is exactly the average of the European Union 27 countries, which is about 11.5% of materials in closed loops, and all the others are not closed loops. So only a small percentage of material is guided in a loop, and this is why we started to look for standards in resource-saving construction, together with the Umweltbundesamt, which is a governmental organization, and the roof organization of building material recycling. And that was before the pandemic came up, and at the beginning of February last year, when I presented these figures. And you have to realize that on the waste side of resources, building construction is responsible for 70% of waste, of the upcoming waste in Austria. So more than half of all waste is excavation material, which goes to landfill mostly, and still 16% are demolition waste, demolition construction waste. So this enormous amount of more than 30 million tons every year is due to construction. But on the resource side, on the other side, we have an even huger number of need, because 200 million tons of materials are needed in Austria every year, and again, 70% is needed for construction purposes. So these two figures don't really go together. So even if we close our loops to 100%, we only get 1/3 covered of the need. So 200 million tons are needed and 60 million tons are waste. And of course, we were looking for a way to bring these two figures together, and the only way for a circular economy in construction is first, of course, to close the loops, but then I agree completely that we have to choose our construction as a more durable construction. So less is more durable in our times, and it's no more the idea of less is more and being light and so on, but less is more durable. It has 200 years to last. And of course, we have to apply much more renewable resources as renewable energy also. So let me give you some examples of our planning practice, where we mostly are consulting other architectural practices all over Europe, and we go through this very quickly, and finally we stay a little longer with the examples of circular construction in the term of construction sites and resource management. So let me show you this competition from last year. It was with Querkraft architects, which are quite famous architects in Vienna and Austria. And we were invited for a retail, for inner city retailer out of the 60s, construction from concrete. And we decided not to tear this construction, this existing building down, but to build on top of it and to use the structure. And this was the given existing building, a retail like C&A and all these Karlstadt in Germany. This is a place in Bielefeld, a site in Bielefeld in northern Germany, where the competition was. And finally, we just took away 40% and we cleared the construction and the structure, and then we decided to keep all the load-bearing structure and to place in new access cores, and finally to put the new architecture as a wooden construction on top of it. So, and the next step was, of course, to create a climate change adapted structure with much more green on it and in it as it was before. And we did some calculations, and when you compare here a demolition and a new building with our procedure, then you can save 90% of CO2 emission just by keeping 60% of the structure and by using renewable resources which does not emit any CO2. And by the way, you are much faster when you choose the second procedure, because the demolition work is much shorter and you build up on a structure which is half given, so even the construction phase is shorter, and this is why it's also an additional advantage. It looks nice. Okay, and another example, a competition that we have won this year with the London office, Searches and Invades in London, was also a retail object, same an inner city retailer which was built in the 60s, and but in that case it was impossible to use the structure because of asbestos, and it was highly contaminated. So we had to choose. We could not use the existing structures, so we were thinking about a low-tech application for a hotel on top of a retail store, and the solution was to choose not an insulated building, but a building completely out of brick, which was cladding a wooden structure like a big ship, a solid construction of wood placed on a base of concrete. So clear separation of materials and of resources were the concept, and the cooling of the building and the ventilation was meant to be as you see on the left-hand side, concrete cool called the system. So you're cooling the building by its thermal mass and using its construction materials to cool down with air, with ventilation air, which is heated by the mass of the concrete itself, and that was the idea. So, and just 1 year before we did that, in 2019, we could not win this competition, but it was the first one where we used that concept for building thermal mass to heat and to store and to cool, of course, energy, and we had to have it was a double application in a way. The submission had to include a version where we kept half of the existing building, which of course we did prefer, and this is the yellow one. So in the comparison, direct comparison, the same idea was to use the thermal mass of the concrete construction inside with building component cooling. It's the activation of the concrete slabs, and to have a monolithic facade which is not insulated but purely made out of brick. And this is actually referring to a very famous scheme where only ventilation is regulated to cool the building, and the installation of the thick brick wall is enough to have a good energy performance. And this principle was actually invented by Baumschlager Eberle, these famous architects who built also the airport in Vienna, and it is called 2226. And I may switch now to the website, which is explaining this concept, because it's really important. It's a really interesting low-tech concept. 2226 is actually addressing the temperature where we are comfortable. So it's the comfort zone between 22 and 26 degrees, which is the gray bar here in this graphic. And the blue lines are the blue graph is the outside temperature, which might range in a year between -10, -15 even in Austria. And at the moment it's over 30 degrees in summer times. So you have this wide range of temperature, but when you use a 70 centimeter brick wall, as you can see on the picture, the building performance is not so bad, and the temperature ranges between 5 degrees and 15 degrees, which of course is not so comfortable. But as soon as you start to use the building, you put in your computer machines, electric light, and also people who work in this building, you see that the range is much more close to the comfort range of 22-26. So the usage of the building is the actual heating. And what about, you see, over 26 degrees is not in the comfort zone. And this is why this building is also operated, as you have seen that, by ventilation flaps, who are opened at night, and of course, as Vahid said, the cross ventilation of the building is the key for good thermal performance. So 2226 is, from our point of view, a very good for low-tech approach in Austria, where you have to cope with heat and also with low temperatures. Let me skip now to our practice on sites, and we have recently published the manual of recycling, even in English, which is featuring the Vienna model, which is a kind of a subsumized work of the last 10 years, where we have tried to use local resources to build with, and point out this. Now let's start with the C.E.Talk, which is one of the hugest urban development areas in Vienna, and you see how huge it is, and 3,000 housing units were entirely built with the gravel and the sand of this little lake and of the excavation material itself. So there were no waste of excavation, and all has been processed to produce concrete on site. Finally, we succeeded in building 3,000 housing units with the material on site. And of course, it was the first mobile concrete unit which had to do such a big job. Normally, we built tunnels with that type of technology, but in that case, it's perfectly suiting also for housing. Pardon me? Can I continue? Is that? Can you hear me? Hello? Okay. So I go on. Sorry. So this is just a graphic showing how the location would be. So our planning process was actually to use the excavated sand and gravel and to process it on the logistics side here. And finally, we could manage to use up to 60% of all building material needed out of these local materials. But the second finding was that we could also use the covering, the upper soil, for the usage of landscape design. And this was finding that we applied this knowledge we did apply to the Wildgarten, a second urban development area in Vienna, where we used this knowledge from the upper soil, because there were very little building material in the ground, and this is the analytic scheme. So near the Danube, you have all this sand and gravel, of course, but far away in the south of Vienna, you will mainly find heterogeneous building material. The soil, which takes for the growth of 2 centimeters, nature needs 500 years, and it's the waste which goes to the landfill when you start to build. As you can see here, not a single construction housing site has yet begun, and just infrastructure is placed, and all up is gone. So this is how it looks like. So this was really a fertile and an important resource which should not be thrown away and should be kept, and this was the first where we see it in storing the whole soil next to the site on the ground. We were renting, and even paying a rent, a certain fee, is more attractive and more cost efficient than to take landfill. And this is our procedure of the so-called B horizon, which you need as a component. And so again, local material, but in that case, for a vegetation substrate purpose, has been processed and could be used entirely. And recently, one of my team members did find out that even Otto Wagner did apply these techniques to use local materials for local building purposes. And this competition in 1914, So 100 years ago, more than 100 years ago, he emphasized that all materials, or biggest part of materials, could be gained on site. And this is the last project now talking to you about. It's the biotoxicity, which is an ambitious project with the idea of putting more green on buildings and on housing, but actually it was a facility, an industrial facility on a brownfield. And this was not our first urban mining site, where we succeeded in receiving more than 60,000 tons of materials for building purposes. So also construction demolition waste is an important resource, but also it was, we did that on site, and the comparison with a non-site facility and a stationary facility is obvious, or makes it obvious that you have to use to proceed 30,000 tons of construction, demolition construction materials takes you 6,000 liters of diesel, but when you take it away from the site and you bring it back to the site and you proceed it in a stationary facility, you have to invest 55,000 liters of diesel. So an on-site processing of materials is the very best solution. So again, local materials means that you have to investigate the ground on which you build, and also the building, the existing building, when you cannot use it entirely. This is not our first, and even not our biggest urban mining project, but it was the first social urban mining project, because 2015 was the year of the peak of refugees. And we were looking for a way to integrate people in the building process, and we found that the dismantling work could be done by social enterprises, and all this manual work could be used to integrate people in Austrian society and in construction processes. So we founded Brussels as a social enterprise to reuse and recollect and sort building components, to reuse it on the site. And this is even better than to recycle, because these insulation panels using or coming from the roof were used to insulate garages and everything which was built. So again, and actually we founded this business model by collecting first the copper with our Baukarussell to get the work paid, not by selling the insulation panels, but by selling the copper. And this previous collecting of copper turns out to be a good business model. So Baukarussell, as a social urban mining enterprise, is using building components like copper and reusable building elements to have revenues, to have a budget for creating jobs, and this budget is applied for dismantling work of building. And actually, it was our last project, and then I'm finally coming to an end. This was, or is, a stadium which are about to work in this summer, and we succeeded in selling 1,000 of these elements on the tribunes to be seated. And as you can see, there's no one left here. And we also collected the copper and everything which was usable, even the racetrack, and all done by social urban miners. And this is our website, and I thank you.
Thank you so much, Mr. Rom. I want to thank you in the name of Dr. Brigitte Gishier. She has technical problems with her laptop, but she has sent me a message and want to thank you so much for your attendance on your interesting PowerPoint and presentation. آقای غبادیان، خانم دودوکشی رایزن فرنگیمون متاسفانه یک مشکل فنی رو لپتاپشون برخوردن، گفتن که از شما و آقای روم تشکر بکنم بابت شرکتتون در این برنامه و من از طرف ایشون از شما تشکر میکنم، از تمامی عزیزانی که در این برنامه شرکت کرده بودن و بسیار بسیار ابراز رضایت و اون بود که بسیار براشون جالب بود، هم در واقع بخشی از صحبت شما که حضور داشتن، بخشی از صحبت آقای روم رو، و خواستم که از شما تشکر بکنم.
The subject of energy and green architecture are much more relevant these days, and the more architects can be pushed to advance with growing architecture, the more beneficial it is the environment. We believe that the combination of oxygen and Iranian architecture can make a big difference, especially in the field of environment. We really enjoyed the speeches and presentation of both architects. Thank you so much. Oxford 21 is our next seminar about architectural competition. We are proud to be with you. Thank you.
There we go. من فکر می‌کنم که من از طرف همه دوستان از شما تشکر می‌کنم. جناب غبادیان عزیز، بسیار لذت بردیم از ارائه مطالب بسیار خوبتون و بسیار خوشحال شدیم. انشاءالله که بتونیم در برنامه آتی در خدمت شما باشیم. سپاسگزارم.
Thank you, Tom. It was great having you. I enjoyed your presentation. Hope to see you in the future and learn more about your great work.
Thank you. Thank you a lot.
Good job.
Thank you for having me. Lieber Herr Rohr, vielen herzlichen Dank für Ihre ganz interessante informative Vortrag. Also in den Namen von Frau Gischier, ich bedanke mich und hoffentlich vielleicht bis bald in Teheran oder in Wien. Sehr gerne. Ja, alles Gute und liebe Grüße aus Teheran. Alles Gute.
Okay.
Ja, حضور گرامی خیلی از شما متشکرم. امیدوارم که بسیار شب خوبی داشته باشین و تا برنامه بعدی در 2 هفته آینده سه‌شنبه شب ساعت 8 در خدمتتون خواهیم.
Thank you.